We're in the process of admitting everyone. If you are here and can hear us, great. Thank you for joining us. Just give us a couple of minutes to make sure everybody is connected to audio, and we'll get started in just a few.
Okay, and so our plan is to go for about an hour and a half, right?
Correct.
Yes. Okay, so we will wrap up in an hour and a half. Okay? Okay, I show us at 10:01 Hawaii time. So why don't we get started? If you are not a presenter or speaker today, please turn your cameras off for now. And then also make sure that you are on mute if you are not a speaker. Okay? Well, welcome to our webinar on AI and wildfire risk. I'm Carl Kim, a professor of urban and regional planning at the University of Hawaii and director of the National Disaster Preparedness Training Center. This event is co-hosted by ResCon International. And so what I would like to do is ask Carrie to say a few words about ResCon, one of the co-sponsors for this event today.
Hi, Carl. Thanks. We here at ResCon are thrilled. Today, ResCon, a resiliency conference, is the premier annual event dedicated to advancing disaster management and resilience practices. Each year, ResCon brings together global leaders, researchers, innovators, and practitioners across sectors to explore groundbreaking ideas that drive safer and more resilient communities. As we gear up for next year's event to be held March 11th through 13th at the Ernest N. Morial Convention Center in New Orleans, today's webinar will give you a taste of the transformative discussions planned for ResCon 2025. So with that, I'll turn it back over to you, Carl, and let's dive in to the
Great.
webinar.
So the National Disaster Preparedness Training Center is a congressionally authorized national center that develops training courses for first responders and emergency managers focused on natural hazards, on climate, and then also the issues and concerns of islands and isolated communities. We're part of the National Domestic Preparedness Consortium, which includes a number of other institutions, Texas A&M, LSU, New Mexico Tech, and then also other partners from FEMA and the federal government. Is Van Romero on as yet?
Not yet, Carl.
Okay. I'll ask Van to say a few, perhaps closing words about the consortium as well too. I do see many other members of the consortium on the call, and so I want to give a shout out to them as well too. We have a really interesting panel lined up of scientists, of researchers, of responders, and others that are working on this very important topic of AI and wildfire risk. We have Dr. Michael Pavlonis from NOAA's Wild and Fire Program Manager for the NOAA satellite service. We also have Chief York and Chief Michael Hernandez from Cal Fire. And then we also have researchers from Michigan State University, Daniel Kent, and then from our team, Jeho Choi, who will talk about some of the work that we've been doing with AI and wildfire detection. AI is a hugely important topic. We did a webinar on AI and emergency management a couple weeks ago for our monthly third Thursday events. One of the takeaways from that event was that it's very important to look at specific hazards and applications of this. And so this is a deeper dive into the problem of wildfire risk. And so I think part of what we were trying to do is to bring people together from different disciplines and then share information and then look forward to some of the things that we can do collectively or collaboratively as we move forward. So our first speaker on this is from NOAA, and I'd like to ask Mike Pavlonis to take the floor here, and maybe you can say a little bit about your organization and the important work that you're doing.
Yes, thank you, Carl, and thank you for having me. So, as Carl mentioned, I'm with the NOAA Satellite and Information Service, where I'm the Wildland Fire Program Manager, and I'd like to take a couple of minutes to tell you about AI-related work in NOAA. But just first, a little bit of context about NOAA and the NOAA mission services that play a role in this problem, and it plays a role in the pre-active and post-fire stages over a range of timescales, from the warning timescale to seasonal forecasts. And recognizing that wildland fire is part of a cascading hazard chain where the fire is preceded by heat and drought, and sometimes followed by hydrological hazards. So there are a range of services that NOAA provides in support of this, and each one of these areas has the opportunity to have AI enhance services and in protection of life and property. And so since I'm from the NOAA Satellite and Information Service, I wanted to tell you a little bit more about what we're doing with the NOAA weather satellites for fire detection and some other applications in regard to AI and how that may fit in with other capabilities. Okay, so one of our primary efforts is the development of something called the Next Generation Fire System, or NGFS, which utilizes artificial intelligence to detect the diffuse heat signatures from fires as they emerge in the satellite imagery, consistent with what a human expert would see in the satellite image. So this is from a satellite called the GOES satellites, which are 22,000 miles above the equator, so it's quite a vantage point. The trade-off here is that you get frequent images, as frequent as every minute, but the resolution is rather coarse. It's about 2 kilometers. So the artificial intelligence can tell you where that diffuse heat is, and you'll see that with a red box here on top of the image where the heat signal emerges. But you can't really pinpoint with a lot of precision of where the heat is within that box. So this is meant to be one of the many tools in the toolbox and a piece of the much larger puzzle. And that's sort of the theme that I'll emphasize here. And this is the detection of you can see how early you can detect relative to the camera. In this case, this is Sonoma County, California. This is actually a structure fire last October. Okay. The artificial intelligence is great, but you have to have a way to convey the information to those who have to make decisions in an efficient manner. And so a lot of effort is going into user interfaces and dissemination services. And so this is just a sampling of some of those capabilities, including an experimental dashboard that automatically detects what may be new fires and highlights them as a function of geography and fire weather conditions, so that users can filter those detections according to their areas of responsibility and where and when they may be concerned about potential fires based on the weather conditions. Capabilities, the NGFS, were recently tested in the NOAA Fire Test Bed in Boulder, Colorado this past summer, which brought together National Weather Service forecasters along with state level partners to to work on improving fire warnings for the public when fires may impact values at risk, and also for improving hotspot notifications to partners in support of incident awareness. So there's quite a bit of information out there on this, but it was a very productive and successful week of testing. Just one last thing is that, it's not only a diagnostic capability from satellites, but prognostic capability. You can actually glean information about the future from satellites when you use machine learning, artificial intelligence. This is just an example of one of the early success stories of the sort of modern day or the present day AI revolution in NOAA. This is a model called Lightning Cast, which takes satellite imagery and predicts where lightning will occur in the next hour. So for situational awareness, for lightning ignitions, as well as for management of incidents where you have crews exposed to potential hazards. This is a capability that provides that intelligence ahead of the hazard actually materializing with the help of machine learning, artificial intelligence. Okay, and then finally, just some key points that I hope will help set up some of the discussion. No one knows this AI tools for wildland fire, or maybe AI tools in general. They're for humans. They're for human decision makers. They're not a replacement for human decision makers. It's the force multiplier. And in our case, with the use and exploitation of weather satellites, it's a piece of a much larger data information puzzle. It's meant to be complementary to other data sources. So when data-rich environments like California, it may play less of a role, but a smaller role, but in places with less data, maybe a slightly larger role. These tools are for detecting and tracking potential fires, regardless of fire management strategy. Not every fire needs the same or is going to be managed in the same way. And no AI tool is able to impact every outcome. There are some scenarios in which information, regardless if you had it or not, may not impact the outcome. And these things are continually improving all the time. And with that, I will turn it back over if I could stop sharing.
Okay, thank you. Thank you for a great informative presentation. I'd like to invite now Chief Hernandez and Chief York from CAL FIRE to say a few words and move forward on. Before I go forward with this, though, I do want to express our gratitude from the state of Hawaii for all the assistance that CAL FIRE has provided for the Maui fire disaster. And so, Chief York, are you ready to go?
I'll start it, Carl, with the introduction. So
Sure.
a little background, CAL FIRE is the California Department of Forestry and Fire Protection. With over 10,000 personnel, we are California's fire department. In addition to the 33 million acres of state responsibility area we protect, we have over 118 cooperative agreements. With being one of the leaders in fire for the state of California, we have to develop a variety of capacities. That includes paying attention to emerging technologies and artificial intelligence. Quite often, when you hear about new technologies, we are hearing artificial intelligence. We have one new program, which I'm in, which is the Office of Wildfire Technology Research and Development, where we look at various technologies, including we did some real-world deployments of some fire detection systems. We were quite disappointed in those systems. They weren't able to maintain power connectivity, as well as had a variety of false positives in addition to the costs associated. But last year, we did have an important success, which Chief Phil Selig is here to talk about from our Intel program within CAL FIRE. With as large as we are, Intel plays a vital role, and I'm going to pass it to Chief Selig for a presentation on this success we had.
All right. Well, good afternoon, Phillips League. I'm the staff chief of our Intel program statewide. So as Chief Hernandez said, we out of the 58 counties in California, we operate in 31 of them. So I'm going to share my screen. I've got a quick PowerPoint presentation that I'm going to cover a few of the different aspects of how we utilize, get my slideshow to work, how we utilize AI. So I'm going to kind of cover a myriad of things, kind of start from who we are and continue into how we're utilizing it and what that deployment of it looks like. So again, as Chief Hernandez had said, we're almost just over 10,000, almost 12,000 personnel strong, and that's uniform, non-uniform, seasonal employees as well. So we have 21 different units throughout the state, and those in our geographical area coordination centers, one in the northern end of the state, one in the southern, there's a lot of coordination that occurs. So any new development of technology, there's quite a bit of a training and development aspect to it to integrate it within. So as we go through this presentation, I'll kind of identify what we had done within the Alert California system and how we've implemented that throughout the state. So in the Intel office or in the Intel program, the legs of it are predictive services. So we have to know what is the state of the fuels, what is the dryness component, what is that fuel moisture of it, what is the seasonal abnormalities, what is projected for the next 7 days, for the next 2 weeks, for the next 4 months, and that gives our decision makers and legislators, as well as our CAL FIRE director, Chief Tyler, understand what we would be potentially facing as that fire year progresses. We no longer have just a fire season. It is not just a shoulders of, well, it's going to be hot, it's going to be dry, it's going to be windy. Throughout the state, as geographical diverse as we are, we have found that it is now fire years. So from that January through December. So currently right now we're in a weather pattern that is hopefully going to hold strong and bring us some precipitation, but also with that comes winds. So we have some precipitation that may fall, but then winds directly after it. So we're able to leverage our predictive services by our relationship with the folks from our federal and other state partners at our predictive services offices. And then we integrate that into our everyday activities. So one of the pieces that we have integrated since starting in 2019 is our close-knit relationship with Alert California. It was initially sponsored by UCSD, University of San Diego. And then we're going to take all of those things from predictive services, real time, and our remote sensing. And how do we collect all of those things, harness the power of AI? And as Michael had pointed out, there's always a human operator, someone to validate that. So as I go through this presentation and we talk about what is the development of that AI and that what came from that machine learning. So we take that process, we process that data, we bring it in, and our processing of the data by collecting all of those predictive services attributes. What is the state of the fuel, the health of the fuel, how much precipitation, what is the wind, what is the geology, what is the geographic features in that area? And we're able to display that into our common operational platform that gives us fire risk forecasting as fire spread prediction analysis. And that's through Technosilva, and that's our wildfire analyst. So we take wildfire analyst, we have all those attributes into them. We make decisions based on fire prediction, fire spread processing, and then we analyze it. Where's the fire going to go? What is it going to affect? What population is it going to affect? What critical infrastructure? Where do the resources are most appropriate to be placed? And then with all good data, it's only as good as it is to get to the person that is going to utilize it the most. And in our case, our number one customer are those that are utilizing it tactically on the ground. If you have all of this huge, massive set of data, but it stays in a warehouse or someone's computer that isn't, decisions are not being made from, then to us, it doesn't assist any of our field users. So we want to make that, in quote terms, shovel ready, so that it is ingestible easily by our first responders, those that are on the ground. So here's the state broke up in our geographical areas between our northern and southern region, and it's broke up in each one of those 21 units, and that'll come to play here in a second. So as those geographical units, each one of those in those unit boundaries have a emergency command center. And we'll discuss that here in a second. So this picture on the right is showing FireGuard. So FireGuard, we developed here in California after the devastating Camp Fire of 2018. Early that year, our federal military partners had come to us and said, we have something that we believe would assist you in early detection and ongoing assessment. So we quickly evaluated it and found it to be of value to us. And what that had given us was the ability to utilize DoD-based assets and bring it to us for that early detection. With that, then came the Alert California system. So again, in 2019, we had developed a relationship with Alert California, and that relationship we have expanded their network. So we currently sponsor just over 200 cameras. There are over 1,100 cameras within the network, within that tapestry. And a lot of the sponsors are publicly owned utilities, are investor-owned utilities. Academia has some, and now our federal partners, the U.S. Forest Service, are now starting to sponsor some of those cameras as well. So we have quite a bit of tapestry. And with all of that camera development comes large data sets. So there's petabytes of data. So early on into our engagement, what we had identified was, with all of this data, how can we harness this data, and what can we develop and turn this into to continue to progress this in a way that we knew that it was where it was going to go. So one of Dr. Neil Driscoll's students at UCSD had quantified the amount of data that they have. So as we talk in data and large data sets and large machine learning and petabytes worth of data, what exactly is a petabyte? So the student was able to quantify a petabyte of data and the multi-petabytes of data that they have stored, that the Alert California cameras have gathered. If you were to take 3.5-inch floppy disks and put the data on those, that there would be enough of those 3.5-inch floppy disks to fill the entire LA Coliseum with that data. So that robust data set has then given us the ability to extrapolate change detection. So when we look out on that landscape and we see something that is progressing, or a smoke or a plume, this system then harnesses that change detection and then alerts us. So why this is valuable and why this system is so widely trusted by ourselves in the fire service in California, and now developing into other states, multiple states. I want to say the Alert West system is now in 7 different states, including the state of Hawaii. So what this system does for us is it alerts us through that AI, and it sends it directly into our emergency command center, so that those folks that are taking those 911 phone calls immediately have an area of interest up on a screen that they're able to take their focus, look immediately at that screen and see a propagation of smoke, and then take immediate action by either sending resources there or sending additional resources if they've already sent a response. So we've seen overwhelming success just in the little bit of time that we had gone through a proof of concept. So our initial proof of concept was mid last year, which thankfully at the time we weren't super busy at a heightened fire year. And quickly, what we had seen was the value added and the success of that camera, of that detection and that alerting ability. So while we had about a 90-day proof of concept with just 7 of our individual units, I quickly expanded that to the entire state of the 21 CAL FIRE units to receive this training and start implementing that in their workflow of their emergency command centers. So what this change detection does is, when it sees that smoke across the landscape, those cameras will then point to it and then alert. So it gives you a confidence factor, and then all of the cameras that actually turn to look at it. So as someone on the other end of the screen looking at it, you can quickly see not only the smoke, but the confidence level that has built into it. So there have been several awards and things that have been given to ourselves at UCSD. This one is the best innovation of Time Magazine. So then it's a force multiplier, as we often say, and we often hear within the fire service, of not just one specific technology, but the added ability, taking what Michael and Noah's team has developed and taking the AI that's built into some of our remote sensing equipment and giving that full perspective of situational awareness. So this is out of one of our cameras, out of an Overwatch system. So now I'll pivot back into FireGuard. So as we started it in 2019, we found that it was very valuable for that early detection and ongoing assessment. And as we continued to evaluate it, what we had seen nationally is it had grown into a national-based solution. So currently there are two secured facilities, one in California out of Sacramento and another one in Colorado. And it's persistent coverage from an all source intel analyst that is gathering data such as this, placing it into, and this was early generation, into a PowerPoint presentation to then be sent to us. So as we quickly had evolved that, and we had seen the use cases of it, and we had never yet before had seen or had the ability to watch a fire from the early inception of the fire all the way through the life cycle. So as it changes, goes through that topography, as it goes through those rangelands. So this gives us the ability to see each one of those spot reports, to ingest it. So what we have done through machine learning and AI is we have ingested all of that through our wildfire analysts, through Technosilva, and they have built a machine learned model that has holistically changed the way we utilize fire predictive software. They have added additional fire behavior techniques and the ability to increase the accuracy of our fire prediction, fire spread prediction. So what this is again, our number one customers tactically. So we take all of these things with the Alert California, with the detections, with the AI from the development of FireGuard, and we place it into our common operational platform, which can be included also on a mobile device. So this is an animation of the largest fire that we had this past year, the Park Fire, that stretched across 3 different counties. And what this is showing is those intel analysts have scribed each one of those polygons as a spot report. So when we talk about resolution of those spot reports, what we're seeing here is at about a 300 to 400 meter resolution and a cadence about every 10 to 15 minutes. So that in combination of what we receive through Alert California helps build that situational awareness, helps build that confidence factor that then we can continue to add those added benefits of this is where the fire is, this is where it's going, this is the confidence, this is where I'm going to place resources, and here's where I need to start some evacuations. So these are just a couple of animations of the fire spread prediction. So this is an animation showing a fire spread prediction in FireGuard and what they were seeing as far as their spot reports, because what it's looking at is the fire affected area, not necessarily where the fire is exactly tracking. So this is showing you that area of interest from the camera system. So this is showing you nocturnally that it's picking up a smoke or a detection. So in the box on the left, you can see just a little bit of a blop of red, and that red boxing area is where that fire is. So as it's looking out across a landscape anywhere from 40 to 60 miles out, depending on curvature and terrain, it's able to identify those. So this is bringing all of these things together and having it in one place and being able to then absorb and ingest all of the different cameras throughout the state in one. And that's the end of my presentation. Thank you.
Thank you. That was really very informative, and it actually gives us a lot of hope for some of the innovations that can be shared. I see that my good friend and colleague, Dr. Van Romero, has joined us. He is not only the head of our consortium, he's also vice president of research for New Mexico Tech and a professor of physics. So Van, can you say a few words about the consortium and some of the work that we're doing on these topics?
Yes, thank you, Carl. Appreciate the introduction. The National Domestic Preparedness Consortium was formed first in response to the Oklahoma City bombing, and then after the World Trade Center 9/11, we really expanded quite a bit. And at first, it was all about terrorism, but as we've evolved over the past 25 years, we've come to take on all hazards, and certainly wildfire is part of that all hazards. One of the things that the consortium, all of our members are focused on is how can we get the best tools, the latest tools in the hands of people who are responding to these major disasters. And certainly AI is a big part of that. I am sorry I was late. I was traveling to my office space here, and there was a accident on the freeway. But I had AI, I'd avoid that, right? But unfortunately, that didn't help. Although on this particular area in the freeway, I don't think you need AI. I think you just need to avoid that particular area. But nonetheless, a lot of our members are really focused on, as I said, on how we can help responders with these types of tools, but also we still have our original mission of dealing with terrorists. The bad guys are using AI as well. And so I think that's another thing that we have to put into our equation is how can we protect ourselves from AI? And sometimes it's well intentioned. Maybe somebody's flying a drone around and somebody's trying to put out a fire. Certainly those private drones are certainly a nuisance. So how can we deal with things like counter UAS as well? So consortium is very active in this. I'm very fascinated by the work that you're doing, and I look forward to hearing a little bit more about it.
Thank you, Van. The next speaker that we have is from Michigan State University. Last week, I was in Colorado. We have a FRA, a Federal Railroad Administration grant looking at wildfire risk for the Class 1 railways, primarily in California and the West. And so we've been looking at drought conditions, burn probability, and then looking at the railway network and mapping some of the risk and looking at various mitigation strategies for that. This is part of a climate change, extreme events, training and research project that is led by San Jose State University, the Mineta Transportation Institute. And so the researchers from not just Hawaii, but also Oregon State University and Michigan State University and other schools met last week. And I saw Daniel's presentation on the work that they're doing, integrating sensor development. And so I asked him to present. Dan is a grad student at Michigan State University and working on many of these kinds of object identification and classification problems. So Daniel, are you ready to go?
Yes, I am. Thank you for that introduction, Dr. Kim. Let me go ahead and pull up my presentation. Right, hopefully everyone can see that. So basically, our kind of sub portion of the overall FRA project that Dr. Kim was mentioning is using commodity hardware to detect climate change related events on rail platforms, including but not limited to wildfires, rock slides, and pedestrians and vehicle ingress, making use of software and hardware advancements originally developed for ground vehicles, as our lab has more traditional experience in connected and autonomous vehicles. So for the portion of disaster detection, we've been starting our work focusing on the wildfire perception task, and the goal is to basically just automatically detect wildfires in camera imagery. And specifically, if we can segment the exact pixels that correspond to wildfires, assuming we can get distance measurements, location, we can help pinpoint the fires much more accurately, determine how big they are. And then from there, we can start providing early warning to other rail vehicles and also communicate outward to first responders to help contain those fires earlier. So a typical way that that's done is you have an image, use layers of convolutional neural networks to kind of reduce down to features, or even just like a binary, is this a wildfire? Yes, no. And then use a decoder network, so you re-expand that so that every pixel then gets your classification. So this is a little bit more difficult than your typical object detection and tracking, because fire doesn't really move and look like a lot of objects that that would ordinarily be put in detection networks. And it can also be accompanied by things like smoke, which can obscure the field of view. So one of the things that we did to help out with this is, instead of just using that RGB image, we also use the optical flow, which is basically how pixels kind of move. So we're using a little bit of hysteresis, a few samples of frames instead of just the single frame at a time, and kind of determining how those pixels are moving around to kind of help with then being able to segment the wildfire from non-wildfire in the image. So part of what makes this task particularly difficult is that data sets with labeled fire imagery are pretty scarce. In all, we found about 415 labeled samples across 4 data sets, and these are examples of the 4 data sets that we have. So Bowfire, D-Fire, Corsican, and Flame. To note, Flame is a bit different than the other 3 in that it is a kind of a drone-based data set, so you can kind of tell in the upper right corner of that image is where the fire is, but it's kind of from above. And for our projects, we are really looking at kind of rail vehicle centric imagery. So, and really few of any of these images are taken along railroads. So we do have some research into trying to augment that. But given the limitations, looking at kind of the results based on compared to other state of the art, our current model with that optical flow layer shows significant improvement over existing state of the art. So average precision is kind of a general machine learning metric. It unfortunately doesn't kind of break out into false positive, false negatives. That's something that I'm going to try and have for future reference, to especially if we can have like a rock curve. But as a side effect, average precision, like increases of 1% are pretty significant. And we do about a little under 2% better than the current state of the art. And we do believe that more improvement is possible in the future, especially given that we do have a very limited amount of data. And just can I illustrate what an improvement in accuracy looks like for segmenting wildfire? You can see that the seg former on the left, there's a lot of kind of false positive that is segmented as fire, but not really. And ours, that kind of those pixels are much tighter around where the fire is. So we're hoping to kind of expand a lot of this work to other disaster types, namely rock slides, other weather events. But we are fairly pleased with what we see, and we do eventually hope to deploy our model on an actual rail vehicle and start collecting data, monitoring in real time. So thank Dr. Kim again for inviting me here today, and I hope that you find some of this research interesting.
Thank you, Daniel. That was really helpful. And also please extend our gratitude onto the rest of your team as well too. So our next speaker is Jeho Choi, who is part of our team. Jeho is a recent graduate of our program and has been focusing on architecture and design, and then also machine vision, machine learning applications. It's AI is really important, not just for congestion management or for automated vehicles and the detection of pedestrians, and managing the roadway, as Van was describing. I think we've used it for other applications. Following the pandemic, we developed some machine vision tools for determining whether or not people were wearing masks or face coverings, and the distance that they were maintaining. One of the things that we have found out too is that if we can develop routine applications such as for roadway maintenance or for other types of activities, when we have to do things like damage assessment, we've got a lot of the tools, the data sets, the algorithms set up. So Jeho, can you talk about the research that we're doing here at the University of Hawaii, and then we'll follow opening it up for some further discussion and Q&A. Okay?
Okay, thank you, Carl. Hello, everyone. I'm Jeho Choi from NDPTC. Today I'll be presenting on how we are integrating extended reality or virtual reality with the machine learning into routine roadway maintenance, in this case for Lahaina fire. This topic has become increasingly important due to the rising frequency of natural disasters, which place more strain on our infrastructures. Traditional method of roadway inspections and maintenance can be time consuming and prone to errors, but by leveraging technologies like machine vision, we are aiming to streamline the process and improve accuracy, and also respond to disasters more effectively. This presentation will walk you through the case study of Front Street in Lahaina, Maui wildfire, and then where these technologies were applied to assess disaster-related damages. We have our own street view. We call it NSV or NDPTC Street View, which had played a critical role in our analysis and verification process. This was developed with the NDPTC and Site Tour 360 with Mike Bors. He is our 360 expert, panoramic camera expert that we constantly work with other type of hurricane or wildfire damages. In this project, we use NDPTC Street View to cross-reference the machine vision analysis with the actual on-ground images. And then by using Street View or NSV, we could see that the increase was due to vehicle being cleared on the street. Oh, so if I go to the next slide. So that was our study area. If you see on the top image, that's from where is it? The Front Street and then Highway I-30 cross section to Kenui Street and then Front Street intersection. And then we chose that site because that was the most damaged site, and then it kind of go through entire the centric Lahaina, where the fire swept or the commercial areas too. So if you see the figure A, pre and post traffic, the graph, you can see how the traffic components, including people and vehicles, drastically decrease in post disaster, indicating a significant road blockage. But there is a little anomaly in the. Can you guys see my mouse? Like that little dip in the red drop right down at the corner. They will show this. Next slide. Here. So if you see that little dip will detect the most damaged area. Oh, so I have to mention that we use Detectron 2 for this model. That's another CNN or convolution neural network that is developed by Meta. And then the reason why we chose this is most of the time we train other FEMA personnel. So for ordinary people or some people who need a baseline trained model, we try to look for the most used open source that is very capable of detecting generic stuffs, like a lot of other stuffs. And then we test even YOLOs or Detectrons. We sometimes train with our disaster images, but most of the time we are trying to deploy with a basic model with the best result. And then so for this panoptic segmentation purposes, the Detectron 2 seems to be the best model. And then so in here, next slide, the conclusion came out. So if you see the result, The building roofs and other structures show significant damage, resulting in increased visibility on the ground and then the sky. And then in the figure B, we can see the average values for traffic and then built environment, and then the sky before and after the event was increased due to the burn down damages. So this insight highlights the level of damage, how quickly we can gather actionable data using machine vision, which can be crucial in disaster response and planning recovery efforts. I think that's
Thank you, Jeho. As you can see, we have a wide range, a diversity of presenters that are working on various parts of this. And so what I want to do right now is open this up for some discussion. First, I want to ask our panelists if they have any feedback or reactions. So maybe starting with Mike. Do you have any reactions to the information that's been presented?
I would just second what Chief Salig, presented. That was, the amount of integration, interoperability, all of the things coming together for humans to make decisions. That's a great example of when of an ideal state or near ideal state, something approaching that. So I really think what they're doing in Cal Fire is something to emulate.
Yes. Yes. Chief Hernandez, Chief York, and any other comments?
I would say it's great what everybody's working on and how we see the overlap. And as Michael mentioned, there's the importance of that human in the loop. AI offers a lot of potential capabilities but for now, it's very important to allow that human to verify those decision support tools.
Mm-hmm. Dr. Romero, any comments or thoughts on this?
This is a fascinating work, and I really appreciate the effort that people have put into this. But I think we're focused a lot on responding. But how about prevention? How can we use these tools to prevent this disaster from starting in the first place, or mitigate it as soon as possible? I think those are things that we need to start turning to once we start developing these tools.
Yeah, that's so interesting because among the things that we've been working on for our FRA railroad project is looking at fuel loading, vegetation management, other types of things that could be done in a way to mitigate or reduce some of the risk. And then also, I think the intelligence is really important so that we can look at El Nino, La Nina effects, and then drought, and then other types of environmental conditions that could be mitigated to reduce both incidents and breakout. I thought one of the things that was really fascinating too was the lightning detection. I know that's a topic that you've been interested in as well too in New Mexico, Van.
Certainly lightning is unpredictable. We think we consider all of these things unpredictable, but the more and more data we get, the better and better we become at predicting them. But lightning and understanding where lightning is occurring relative to fuel sources is certainly an important thing for a quick response. And as we get better and better satellite data, we cover a bigger territory, but we still have the fidelity that we do with ground-based instruments. So I think we just have to take advantage of the data that we can generate through all these various sources.
Yeah, and Van, I know that you lead the space sciences efforts with the telescopes and other things that you're doing at New Mexico Tech. We've been looking at doing a NDPTC or consortium class on satellite capability, satellite applications for DRR. And so that may be something that we can do collectively and reach out to we used to have a small satellite program here at the University of Hawaii. We have some of the researchers that were involved with that as well too, because I think oftentimes the satellite is the first ones in terms of this. And so thinking about the ways to integrate not just the satellite, but aerial imagery and then the drone imagery. As you know, we developed FEMA's first drone class many, many years ago. We've been using it for the volcano and for other hazards as well too. And I think the technologies have greatly improved some challenges in terms of equipment and other things to work out. And then as Jeho showed, what we've been putting a lot of emphasis on is our 360 image capture. We have the same cameras that Google Street View uses. We've worked closely with Google Street View on this so that we can do these before, after image captures. But a lot of it is very impressionistic. And that's why we need to be able to better quantify this through the types of object identification, machine vision, machine AI data capture. And so much of this is about data reduction, throwing the stuff out that we don't need and the stuff that we really need to focus on. So I think these are all really important topics.
Carl, you mentioned relying on all the assets. I actually had this discussion this morning when talking about space science. Space science doesn't start at the top of the atmosphere. It
Right.
starts just above the ground, right? From drones all the way up to satellites. There's the information that we need to be integrating into what we're doing.
Great. Okay. Daniel, any comments? Anything that stands out that you wanted to add?
I guess one of the things that definitely, and there's been some work on it that's good to see, but definitely some more intercommunication between different agencies, different organizations that have data on wildfires, both active and historical, would be definitely helpful in helping develop these methods, as well as in the response, try and make sure that all these systems are interconnected so that one agency is aware but others are not, that could potentially cause fires to spread out of control or damage things needlessly.
Yeah, I think one thing that you point out too is that we really do need to share these databases. You mentioned the four kind of principal databases that you're looking at, and I know that when we were following the Lahaina, we mapped all the locations of all the 2,777 burned vehicles that were there. And what we wanted to be able to do was to come up with a library or catalog of burned vehicles so that we would be able to identify the make and model type, the extent of the damage, and so forth. That is still a work in progress as well too. One of the things that we were trying to do was to detect the difference between an electric vehicle versus a conventional internal combustion engine on that by looking at the imagery as well too. These are the types of works in progress that I know that we've got to do more work on. But again, thank you, Daniel, for your comments. Jeho, any questions or comments or anything to add to this?
Oh, thank you, Carl. Thank you, everyone. Yeah, especially with the data set, I think in at least in this group, if we can share some of the data set we have been collected, because I see a lot of raw data that have a potential here. And then if we can collaborate, it will greatly help our development of better detection models.
Great.
Thank you.
Yeah. Thank you. Thank you. All right. With that, anyone else from the panel want to say something, or before I open up the floodgates here to the people on the call?
Sure. I'll just
Go ahead.
add to your when you talk about the pre-fire or how we can utilize some of these tools and data sets. We utilize currently the LiDAR data set throughout the state for determining areas that we could that would benefit from fuel reduction. So not only that pre but utilizing a lot of that imagery and data collection. But then we can run fire simulations or fire spread predictions to see what the fire would do in that environment. And that helps us identify areas of concern, much like our very high fire severity zone or high fire severity zones.
Yeah, that's really interesting. Actually, Daniel and I were just talking about that because we've been trying to integrate some of our LiDAR aerial, ground base, and then other LiDAR equipment that we've been testing and working with, primarily in the context of the Lahaina fire, but we've actually used it for other applications as well too. So I think I mean, part of the problem though is that we talk about the petabytes of data. I mean, once we start doing LiDAR, you know, things really blow up in terms of the processing requirements and so forth. Any other comments? Let's open it up for questions and comments. Lydia, are you on? Are you monitoring Q&A?
I can take the Q&A. Philip has already started to answer the first question. I think the first three are for Philip. I know you're currently answering them, but the first question was, what tools do you use to predict the wildfire spread? And could you describe the prediction procedure?
Great.
Yeah, so our fire spread predictions are automated. So every time our computer automated dispatch system, our CAD, identifies a wildland fire that was dispatched, or we have received a new fire guard alert, there's a fire spread simulation that occurs. So within about 20 seconds, it is automated. Unfortunately, the inaccuracies that we've seen is it's based on a roadway-based system because it's driving responders to that area or that emergency. So it's often not as the point of origin. Sometimes it is, but if you're driving on a freeway and you see a fire on the side of the hill, then when you call 911 or the emergency response number, then it plots it to where you're driving, your location is, and runs a simulation. So we have folks that work in each one of those 21 units that then say, well, this is actually where the fire is. So within a few minutes, they'll identify based on the first engine company that responds or the Alert California, and they'll be able to pinpoint accuracy within that lat long and then run an additional fire spread simulation.
Yeah, thank you. That's really helpful to know that. For those of you who are on the call, if you can put in the Q&A, you know, some of your takeaways or other questions that you may have that we'll be able to sort of get to as well too. One of the things I wanted to do is I know there are people that we have worked with, part of the NDPTC team or part of the National Domestic Preparedness Consortium. It would be great to hear from you. I also see David Rother, who's part of our wildfire Chrissy project. David, do you want to say a few words about our project? I know you've been heavily involved with our project. David, are you on?
Hey, Carl, this is Ted. Can I make a few comments and then
Sure,
while
go
we're waiting
ahead,
for David to
Ted.
come on? Yeah, I really appreciate this incredible wisdom and knowledge coming forth. I wish I was as smart as 1/10 of you, but I am honored to be Carl's developer of the UAS program of 10, 15 years ago, Carl. Anyway, just a quick one. I'd like to introduce George Purdy online here. Then I have to run. I did not expect to this morning, so I had some other things, but number one, in I think our view is that all of the work being done, as it sort of came up a little bit earlier, has to be compressed into some information that's useful in a reduced chaos way and reducing stress on the commanders who have to receive it and make decisions. We certainly find that if we have new information coming in, it may be something they can't react to. They're not trained for it, don't know what it does, don't have any confidence in it because they never saw it before. So educating the receivers of this information and generate through tabletops and other ways to make the value come forth is as important as generating the value in the first place. So I'll say that George speaks from this perspective of everything we should do, everything we do should be in the direction of reducing chaos. So kind of an aspect here that's interesting is how do we measure what's the figure of merit of this information all coming together? How have we reduced time interval, time response? Have we reduced confusion and stress in the EOC? Exactly how do we think about that? And I'll say it's not just here, it's also in combat operations and every place else, the same exact question occurs. And with that, Carl, I must depart.
Okay, thanks, Ted. And it's great to see George as well, too, who was really instrumental in when we were doing the data capture with the 360 cameras and integrating the drone imagery for Lahaina. George, you want to say a few things?
Hello, everybody. Great presentation. The information, I love to see firemen up there. We always take a lot of these research. We look at what fits the event. For the preparedness part in what Dr. Vaughn was talking about, how do we take this information? We always see from firefighters the disaster point of view, but I like to always reverse engineering on what is today, what was the past. A lot of these things for fire and flooding events, it comes down to the environment, the large landowners' responsibility in taking care of the land. I can see a lot of this information helping our agricultural industry, our forest industry, to get more funding to actually make the landscape better than where it's at today. So that's part of what, on a large scale fire prevention, to slow or mitigate these large wildfires, is really getting the community involved in taking care of the environment. So finding good people that can take this information, go back to their communities, and educate or interpret what we know today at the level that they are at presently, and encourage them on how to support when they spend their tax dollars, that it's okay to raise taxes if it's protecting us, or to help mitigate government in lawsuits that end up that us as the taxpayer gets increased because of bad mistakes that the government made. If we could educate our community on not suing the government on mismanagement, but if we have the technology today and the information today, how do we apply it to help mitigate government lawsuits and take that money that we spend on payouts and invest it in our local communities and environment around every single town? That's what I look at from an island perspective. We got no place to run but the ocean. How do we encourage large landowners that, yes, you can buy these large pieces of land, but you're still responsible for your yard causing problems for the community at large? That's what I gathered from Lahaina. And one of Lahaina's issues is no water. They ran out of water. There's no way to stop the fire. But with climate change today, when it rains in Hawaii, it pours. Is there anything being done to help the land collect the water when surface water runoff? We need to figure out how to slow that water down, have it penetrate the landscape, and put it in the ground. So it's really coming down to healthy soils. And I'm really encouraging our emergency management here in Hawaii to really look at our emergency plans as fire and flood. All these other types of all hazards lead to those two. These incidents always going to lead to fire or flooding. How do we address it in the preparedness part? If we focus and re-engineer from fire and flood and reverse engineer it back to getting it where it's small, it's controllable by local municipalities, you don't have to really call in all the mutual aid support. I think that's where we catch it in the incipient stage versus the blown out of proportion, call everybody in and come in. You lost control at that point. And that's where, when you lose control, the communications to me is very important to regain chaos, control chaos and reduce it back to a controllable level. That's just my experience in the department. And what I provide as what we do on the airport firefighter side, we only got 2 minutes to control that emergency when a plane crashes. So we always start at the high end of the fire scale to reduce it to manageable again. So I come from that perspective. How do we control chaos? That's key. Once you control chaos, you control the community, and then you get the community support after that because you help them understand what's going on. So that's what we saw in Lahaina, was just complete chaos. And any of these large disasters that happen, that's where I see we can make a big improvement using AI, all this information, vision learning. It really helps the mindset to stay calm, especially in the emergency manager's position and the incident commander and unified command. That's where it starts at the top to keep everybody calm and collective and make good decisions. That's all I got.
Thank you, George. I also see many of our other partners. I see Suzanne Frew on. Suzanne, do you want to introduce yourself and say, ask your question?
Hey, Carl. Hello, everybody. Good to see you. Great webinar. Thanks. I was asking the question about, and Jal, maybe you can answer this or anybody who worked on it. So in your data gathering, in your data set, when you were looking at Lahaina, did you build in anything regarding the unique Hawaiian cultural structures, whether it was regarding buildings, transportation, anything there, but specifically with the Hawaiian cultural values in mind?
Yeah, that's an important comment and question. One of the things that we've been working on, because it started as a wildfire, then became a grasslands fire, but then became an urban fire. One of the largest oldest historic districts in the nation, and certainly in terms of figuring out not just what happened and the impacts and what we've lost. I think looking at the fuel loading, these buildings that were not built up to code, the densities, the other types of factors that occurred versus, a more traditional use of the land, management of the land. I think that was part of some of the points that George was getting into as well too. I'm going to suggest that is a topic of further discussion, how to integrate AI into understanding of place, cultural landscapes, and so forth. So I don't know if anyone on the panel has any reactions to that, either from the NOAA or CAL FIRE perspective. I know the consortium has been working with tribal as well as other communities as well too. Any reactions from anyone on the call?
Well, if anybody's going to be at the IAM conference, I'm going to be speaking on the democratization of AI for whole community and addressing some of these issues. And there's some stuff going on at UH that I'm particularly interested. So I think this would be a really good follow-up discussion.
Right. Yeah, thank you, Suzanne. Suzanne was heavily involved with the development of our social media classes as well too. And when we started, it was about pushing information out as opposed to the crowdsourcing and all of the ways in which that we can integrate the feedback from human sensors as well as the other sensor development as well too.
Yeah, I got one more to answer to that question. So I'm like I said, I'm a student of disaster. So when I watched Helene run through North Carolina, when I was watching the community speak on TV, they spoke with the same sense that the Lahaina residents spoke at. That's what really popped out when I started listening to all the stories. Those communities, once you cut off the arteries, they became islands themselves. It was a repeat of what just happened to Lahaina a year later with those 2 hurricane events. All those communities and having those people speak the way they spoke. And the FEMA folks that were getting threatened up there, is exactly what had happened to here in Lahaina. So closing that gap, having our fellow people understand that our responders at this point were on the edge. There was nothing they can do. So that's where I always come from the point of that chaotic moment. How do we control that first so we can help the community understand what's happening, that quick response? And it's a gap that's accomplishable to achieve with all this information and AI. That helps the people that makes the final decisions to make better decisions quicker. That's where I see AI helping us. And a lot of the community that is afraid of AI, I try to explain it. It's a program that helps eliminate redundancy. And when you have small departments, small government infrastructure, and people that are trapped, and you have your operational team not there, what can you do with the amount of human folks in an emergency operation trying to help restore a whole community? That's the task at hand. We adopting all this information, all these equipment, taking pieces to every community and see what fits, and then educating the community on what they're buying. That's the big buy-in. That'll.
Yeah, thank you. Thank you, George. I think that's a really important point about how we use this information, how we push this information out. You know, we started a project some years ago on misinformation and disinformation, and you know there are increasing challenges with this as well too. And so part of this is getting at, you know, the underlying science. We've always had, you know, good science, bad science, sloppy science. But now we also have to deal with the kind of intentional distortion of information, and what are some of the best practices to manage that in this information age. I want to give time for some of the technical questions to get at. I see Brandon.
One second, Carl. While Suzanne is still unmuted and on video, we did have a question. When is that session, Suzanne, at IAM?
Tech Talk. It's going to be in the Don Lumpkins Tech Center. So, and that's to be determined.
Okay, thank you.
It'll probably be Tuesday or Wednesday around 1 o'clock, either one of those days.
Okay, thanks, Suzanne.
Great, thank you. Brandon, are you on?
I am. How you doing?
Great to see you.
You too.
Yeah. Brandon is with MXV Rail in MXV Learning Institute, one of our partners that we work with. So Brandon, can you ask your question or comment?
I was just curious as to why thermal wasn't being utilized for the wildland fire detection versus the RGB cameras.
That's to Daniel, and then also CAL FIRE, maybe?
Yes.
Yeah. Daniel, why don't you go first? Use of thermal.
So probably one of the biggest issues with thermal is that you have functionally a lot lower resolution. And if you think about how cameras work, lower resolution means you can't really pinpoint it as accurately. I know I haven't personally done any work with using thermal or near IR cameras with for specific fire detection, because it's, you know, this is a fairly new topic, but yeah, the resolution concerns would be probably my biggest concern with trying to do that. Yeah.
Okay, thank you, Daniel. How about from NOAA or from CAL FIRE? Any reactions to that? Use of thermal imagery.
I'll add a little bit as I deal with some organizations that are pushing thermal imagery. One weakness they add is that thermal imagery cannot tell what is causing that change in heat. Might be a campfire, might be a vehicle, might be something else. So although we do use thermal imagery for some things, we use multiple different types of sensors. But one of the downfalls with thermal is it can't detect what's causing that heat change.
Right.
But neither can RGB though.
That's why we use multiple different types of cameras. I'm just to say one of even the detection systems that go with thermal, they do acknowledge that shortcoming.
Gotcha.
Great. Any other points to make on this?
And RGB camera data is far more common, so there's more data to work with. Another consideration.
Yeah. Go ahead.
Most of my experience with AI and detections like these are with hot bearing detectors and things along those lines. So I was just curious how the two sized up.
Yeah, my question is actually for CAL FIRE, and looking at both these RGB cameras that are, you know, stationary versus attached to mobile platforms, because one of the things that we're looking at is strapping cameras on trains, for example, that are in remote areas. And I think, you know, motion adds another challenge in terms of detection and so forth. And so I'm wondering whether, you've looked at the deployment of these cameras on drones, on other moving platforms as well, too.
Not necessarily the ground-based technology, because those are calibrated, and they're calibrated terrestrially and topographically. So to get something with a X, Y, and a Z axis, you wouldn't be able to have it when configuring it to a ground speed. All you would be able to do is say, as it passed, there was something here, and this is the area that it passed through. We do have other things that we utilized, including the public utility companies have Forest Watch, that is just basically a piloted plane that flies in a specific area. When we have large lightning detection, that are large areas of lightning that has occurred, then we'll often send our fixed wing platforms out to look for smokes across that landscape as well. So it happens, but not necessarily with the cameras that are ground mounted.
Right. And yeah, and so this is the exciting work we're doing with Michigan State and others, where, we started with a railway network because that's a more constrained network, and we can get more ground control for the sort of a known area or region, and that there are things that we can do pre-disaster in addition to when there's an area of interest or concern that emerges. And so that's part of the, I think, development work that we're engaged in. And I see others on the call that are struggling with these very same types of technological concerns, but actually, how do you operationalize this? How do you ensure that there's adequate power, communications when you need it to get the ground control and so forth. So, are there other questions as well too? I think Sarah.
Yeah, we have a number of questions actually. So I'm going to run through them so we can hopefully get through all of them before we end today. Sherry Nelson asked if the information is published. I'm not sure which information, but if your research is published from our presenters today, could you please go ahead and put that link or location in the answer, or you can chat it to me and I'll put it into the answer. Philippa Burgess asked, can you talk about the application of AI to burn scar recovery analysis? And would anyone like to take that?
Yeah, there's a lot in this area as far as research. We look at the fire radiated power. So taking the tool set that Noah and Michael's team have developed and doing a reanalysis of that. We also have teams that go out, our watershed response team. They'll go out and actually do ground measurements along with contracting through USGS. So then they'll look at a large area landscape and they'll do a deep dive burn analysis of is the midden soil still there? Is it turned into red ash? Because when we talk about cascading disasters and die off of genius species that are within those waterways, that also affects a lot of things. Catch basins, how much soil is there? So there is a lot that goes into that burn area analysis.
Yeah, and I think that also kind of fits with some of the work that we're trying to do to look at landslide risk and detection of, rubble on rail tracks and other types of object detection as well too. So thank you for that. Go ahead, Lydia.
Sorry. Jeannie, sorry if I got your name wrong, asked, as responsible safety tech creators, what harmful outcomes could happen from application? Intentional or unintentional, and what safety measures have been put in place to prevent and mitigate such potential harm?
I could tell you that the fire prediction, fire spread analysis has to be from a trusted source. So we're really within FireScope and within the state of California and nationally, I sit on several groups. We're really identified attributes that are from trusted sources. So as companies and startups and consortiums come in and say, we have this new fire spread analysis that we want to employ, for one, there has to be some kind of trust in the system, but you also have to have trust in the data in those inputs that are there. So rather than just building a fire spread model that looks like water falling off of a bridge and putting that on a social media and saying your house, your structure is going to be affected by this, we have seen harmful outcomes with specifically those tools.
Yeah, and I think this topic was also covered in our previous Third Thursday event as well too. And so maybe Mel or Kung can put the link for that recording as well too. I think that's this whole notion of trust is very important, and I think that there are some important lessons that we've learned about establishing joint information communications and so forth that that we can do with this. Lydia, other questions?
Yeah, a couple more. Dennis asked, curious if anyone is integrating the sensor camera data into public alert and warning systems and or GPS navigation evacuation systems.
So right now, the alerts or the detections that come from specifically Alert California are integrated within our emergency command centers that they make those determinations. Right now, we haven't made that system into a forward-facing. I was with Michael here a few months ago in Colorado, talking about how do you message out and utilizing some of that known sources, again, those trusted sources, who would be the best agency or agencies that would then say there's a wildland fire, there's an emergency within this area, and then what mechanism does it get pushed out on? What platform does it get pushed out on? Other than Google Maps that pulls in all of our wildfire perimeter data into their system, and that it will alert you. Waze, Google, any of those, Apple will alert you that there's a wildfire in the area. But as far as a from the camera based system to alerting mechanism into a navigation system, right now we don't have that.
Yeah, I see Greg Hamp on from PDC. PDC is one of our partners that we've been working with for this FRA project and using disaster aware as one of the platforms for pulling this information together, but also sharing it, and then also potentially linking it to disaster alert. Greg, can you say a few things about that project? Are you still on?
Absolutely. Can you hear me okay?
Yes.
Yeah, we are a major part of our challenge on the project that we're working on with Carl is visualizing the work, especially the work coming out of Carl and his partners, bringing that data in and making it effective and usable. One of the things I found most impressive today is the gentleman who were presenting from Cal Fire. I have the impression that the data you're showing is useful to you on the ground in dealing with the fires, which is what makes the most important thing in terms of presenting this. It's not just sharing the data, here's what we've learned, but actually putting it out there so that disaster managers and decision makers are able to actually not just be able to use it, but use it quickly to make determinations and to allocate resources. And so I was left with a great amount of confidence that the work you guys have done is useful in that regard and able, or at least on its way in development, to being able to make those kinds of decisions as opposed to sort of just a data exercise. And that's kind of the takeaway I'm getting from all of the folks I think that are weighing in, is how to turn this into actions, both in the immediate, long-term, preventive, and that's what we keep trying to do. We're also working with some AI, and I'll just leave you with one other takeaway we've got is as we're working on AI, we also start to realize we have data sets that we're sitting on that are very useful. Once you start to get into it, you start to realize that sometimes the data is right there in your own house that you hadn't fully appreciated.
Yeah, thanks for that for that. I mean, and what often happens, and this is one of the challenges, is that there have just been so many incidents that have been coming that, we're having to drop everything and turn to something else. And, and so part of this is how do we sort of sustain this? How do we create these kinds of platforms for knowledge exchange and curation, and so that we're not starting all over every time these events occur. So, Lydia, any other comments or questions that you
We
can
do
see?
have one more question. Does this tool also work for wildfire approaches to the urban area? And follow on to that is, what fuel model do you use for urban areas?
That's for a CAL FIRE, right?
I believe so.
Yes.
Yeah, so it does. So we take the three data sets that are currently available to us, one including the Microsoft building footprint, and it's ingested into the base layer of the software. So it knows where all of those structures are, and it changes the fuel type of those. So whether it was a grass model, a shrub model, a timber model, a slash model, it modifies the actual simulation as it does the progression run. So if it's approaching a large commercial area, it will change the fire spread prediction to that. What we don't quite have yet is modeling of the ember cast or the spot fires that would come off of that. That's the next development, because what we see a lot with the urban areas is the structure to structure spread, or that firebrand or fire cast that would come from them that would continue that propagation of that fire.
Yeah. Yeah, that's really interesting. So in addition to the lightning issue, the other thing that we're focused on is the volcano hazards as well too, and the potential for ignition and spread from volcano risk as well too. So there's lots of stuff that we can keep piling on to this as well. Any other questions or comments? Any closing thoughts? I see we have about 3 minutes left before we wrap this all up.
Carrie did want to just remind everybody, you can join Carl and crew at ResCon 2025. Carl is doing a lessons from recent wildfires panel there in beautiful New Orleans, Louisiana.
March 11th through 13th, 2025. So I'm hoping that we see many of you in person there at the ResCon meetings, or in terms of the ongoing work that we're doing with our FRA and DOT projects as well too. Obviously, for us, we're trying to link this back to the training courses that we have on evacuation and evacuation planning for this, because how do we alert people, but how do we get them out in time, and both for self-evacuees, which to us, it's a congestion management problem, and we want to get them information as early as possible and get them out so that they don't get caught in the traffic. But I think the major area that we have to work on is assisted evacuation. And so looking at the risk of not just wildfire risk, but the exposure, the sensitivity and the capabilities of different groups to be able to process the information, but then also take precautionary measures. I think that's really important. Okay, any other comments, closing thoughts from the panel?
I have a quick closing thought. So prioritizing and assessing tech gaps or information gaps is just becoming increasingly challenging. Now, the influx of new capabilities is like impossible to keep up with. And older tech, probably has value that has gone completely unexploited, because there hasn't been enough time to apply modern day machine learning, artificial intelligence techniques to it. So like in the satellite world, it's hard to make an assessment is a new satellite system needed to meet a capability, or can an existing one do it with just, better techniques? Those are big investment decisions to be made. And then with the context of all of the other tech. So just putting it out there that this is exciting time, but it's also extremely complicated to make decisions about what investments are going to bear the most fruit.
Yeah, thank you. That's a very valuable comment. Dr. Romero, any closing thoughts?
No, thank you for hosting this. It's been very enlightening. I think we're just on the verge of the capabilities that we're going to realize from AI, and so it's going to be an exciting journey.
Yeah, thank you. I see we are now at time. I want to close by thanking our great panelists for their participation, for your time, and then also our team at ResCon and at NDPTC and the consortium for helping to host this event. Thank you all, and we do hope to see you in person in the near future. Aloha.
Aloha.